Okay, today I'm going to look at B7 of your question. So B7a, which states 1 plus x, 6 minus x less than equals to 8, negative 8 rather. This one is a quadratic inequality, so simply what we do first is we will simply expand. So I get 6 plus 6x minus x squared is lesser than or equals to negative 8. I rearrange the equation. Plus 6 plus 8 is plus 14 is less than or equals to 0. I multiply both sides by negative 1. So I get this one is greater than or equals to 0. Okay, quadratic inequality, simple thing. First, we try to factorize. So I get x and x minus 7, okay, plus 2. Right, now here's what we need to do for quadratic inequality. What I do here is this: I have to draw a graph. Okay, notice that this is x squared, so it will be a quadratic graph. Then the roots will be plus 7 and negative 2. So I just draw a graph through. Okay, negative 2 plus 7. This is x. Notice that I want the graph to be greater than or equals to 0. So I'm looking for things above the x-axis, which is down here and down here. So at the end, what the two inequalities I get, if the graph is to lie above here, the x values must be lesser than or equals to negative 2, or x is greater than or equals to 7. That is B7a. I can do B7b now for you as well. Okay, B7b works like this. I copy down the question first. It's lesser than x plus 1 and x plus 3. Same thing as well. What we do here is we just expand everything just like above. So you get 2x squared plus 4x is lesser than x squared plus 4x plus 3. Similar to above, we collect all x terms onto the left hand side. So I get x squared. Alright, 4x minus 4x is 0x minus 3 is lesser than 0. This one a bit trickier when we want to factorize this, but it will be x plus root 3. X minus root 3 is lesser than 0. So what I should get here, similarly, x squared graph. So I just draw a smiley graph. The roots are root 3 and negative root 3. So I get negative root 3 and positive root 3. Now this one is a bit different from above because they say that they want the graph, this graph x squared minus 3, to be lesser than 0. Lesser than 0 will lie below the x-axis, which is this region. And the x values which actually describe this region will be x is greater than negative root 3 and lesser than root 3. And I'm done with 7b. Okay, now next question is same for this one, A6. A62. Okay, let me look at A62 now. Okay, A62. Find the values or range of values of P for which the equation has distinct real roots. So I'll write down x squared plus px is equals to plus 8 is equals to p. Then I rearrange my equation in this case. Let me see. Alright, let me rearrange the equation. Okay, x squared plus px plus 8 minus p equals 0. Now they say that they want distinct real roots. So for distinct real roots, b squared minus 4ac, it must be distinct real roots. B squared minus 4ac is greater than 0. So I get b squared minus 4ac is greater than 0. Get p squared plus 4p minus 32 is greater than 0. This one similarly, it will also be a quadratic graph. So what I get is p square. So I factorize here first. P plus 8, p minus 4 is greater than 0. Same thing is a smiley graph with, now the axis is p, then the roots are 4 and negative 8. Greater than 0 means I want it to lie above the p-axis. So the final inequality I get here is p is less than negative 8 or p is greater than 4. And I've solved for A62. And that concludes the questions you asked, I believe. Press